Welcome to my 90-day SAT prep series. Today is day 80 out of 90, and today we're going to be doing a similar review to that you will see on day 90. Day 90 obviously being the day before you're taking your SAT. Hopefully you scheduled this 90-day SAT prep series to have your SAT on day 91, so the day after the series ends. So that means that day 90 then I'll be doing basically a review and prepping you for that next day. So it's going to be really specific to you taking that SAT that next day. So what I want to do today then is do a similar review to that review that you're going to see the day before you take your SAT, since you do have SAT practice test 10 scheduled for tomorrow. That way you can kind of understand if there's anything that you want to review on the side or in addition to what I'll show you on day 90. So in today's video, and what you're going to see on day 90, is going to be a pacing review to start. So I'll go through and review the pacing guidelines and things like that. That'll take me right around 8 minutes. After that, I'll go through a reading passage, kind of showing you what to look for, dealing with pacing, things like that. After that, I'll go ahead and do a review of the grammar rules as well. After that, I'll do a writing passage, right, keeping it in good pacing there, obviously, as well as pointing out key things to look for. After that, I'll do a review of the math formulas and equations you need to know. In addition to that, I will do some math no calculator problems. I'm not going to do a whole practice test, but I will do some problems to review, some math with calculator problems as well. And then in today's video, you're not going to get the final tips because they are specific to you taking the real SAT the next day, right? It's just kind of some final things. So in today's video, you're not going to get those, but on day 90, you will. So with that, let's go ahead and get started with today's video in the pacing review. So we're going to start the review of the pacing for each different section of the SAT with the math no calculator section. So the first thing that you're going to want to do is you're going to want to answer multiple choice questions 1 through 9, since those are going to be the easiest questions. And then after that, you're going to want to go and answer the free response questions 16 through 18. Okay, so at that point, after you've answered 1 through 9 and 16 through 18, you've answered all of the easier and mid difficulty questions on the math no calculator section. At that point, after answering question 18, you want to take a look at 19 and 20. If 19 and 20 look easy to you, then go ahead and do them next. Then go back and answer 10 to 15 in that order. If they look difficult, then go back and do 10 to 12 next. Now after question 12 at that point, you'd want to go back and answer 19 and 20 before answering 13 and 15. Okay, so that's how I recommend pacing the math no calculator section. Now let's take a look at the math with calculator section. So pacing the math with calculator section. Once again, my suggested approach, you're going to want to start with those easier to mid difficulty multiple choice questions. So on the math with calculator section, that's going to be questions 1 through 18. Now after question 18, I recommend taking a look at 19 through 22 of the multiple choice part. If they look easy, go ahead and do them. So if you get to 18, you look at 19, looks easy, go ahead and do 19. And then if 20 looks easy, do 20. If 21 looks easy, do 21. If 22 looks easy, do 22. Okay, if at any point in 19 through 22 you find one that looks really difficult, then go on to step 3, which is going to be answering free response questions 31 to 35. So free response questions 31 to 35, they're going to be those easier to mid difficulty questions for the math with calculator section. After answering question 35, take a look at 36 to 38. If they look easy, go ahead and do them. If they look difficult, then go back to the multiple choice. Okay, so if 36 to 38 look difficult, go back to multiple choice wherever you left off and start going those through the multiple choice until you get to if you get to like 24, and then after 24 looks difficult and you know that 36 to 38 looked easier, you can go back to 36 to 38, but try to get through all the multiple choice if you go back to it, okay? And then after you're done with the multiple choice, come back and do 36 to 38. Now, if 36 to 38 looked easy to you and you went ahead and did them, then obviously you're just going back and finishing out the multiple choice. So that's going to be your guide to math with calculator pacing. If you want to pause the video, take a minute to look through that a little bit more, you can do that as well. Same thing with the no calculator pacing. But yeah, that's your quick review on pacing with the math sections. Okay, so now let's talk pacing with the SAT writing section. All right, so for the SAT writing section, obviously as you read through the passage, you're reading for different things than you are reading for when you do the reading passage. So as you read through the SAT writing passages, you're looking at things such as tense of your verbs. You're looking at things such as singular or plural subjects and singular or plural verbs, parallelism. You're looking at order of ideas, modifiers. You want to watch out for dangling modifiers, identifying independent and dependent clauses when you have to do a combination of sentences or figure out where commas need to go, semicolons, things like that. You want to pay attention to the relationship between ideas and between sentences and paragraphs. Another thing, if you see a 1 at the start of a paragraph, as in next to the first sentence, and then you see a 2 at the second sentence and so on, then what you want to do is find which sentence you're being asked to place. So go ahead and go to the question that asks you about placing a sentence within that paragraph or deleting or adding a sentence, whatever it may be, and go ahead and read what that is and come up with what should come before that sentence and what should come after it. That way you can place it as you read through the paragraph, so that way you don't have to reread the paragraph in order to place the sentence. Okay, now if you see a 1 above a paragraph and a 2 above the next paragraph, it means you're going to be asked something dealing with different paragraphs, in which case it can be helpful to go to the question that asks about the different paragraphs and figure out what it says, so you can sort of place whatever sentence you have to place, or find the order of the paragraphs as you read through, so you don't have to read through twice. Okay, so that can save you some time as well. All right, so some questions which are going to require you to read on before answering them. So these are going to be questions that I have some examples here. So these are going to be questions that ask you about introductions to paragraphs, transitions between sentences, contrast and comparison between paragraphs and sentences. Sometimes questions such as should this sentence be kept, added, or deleted, you have to read on a couple sentences or one sentence in order to find if it should be kept, added, or deleted. Which choice introduces the information that follows it? You need to know which information follows it. Which choice is consistent with the writing that follows it? You need to know the writing that follows it. So anything that asks about things that follow it, or keeping a sentence, deleting a sentence, things like that, you're going to want to make sure you get some context by reading on a little bit before you answer them. And then as you're reading on, go ahead and answer any questions that arise as you're reading on. That way you don't have to reread that part again either. And then go back and answer the one that you had to skip over to get context on once you get enough context for it. So SAT writing section, you're just going to go through the passages in the order 1 through 4 because there's really no science section versus literature section of being stronger in one than the other. So you just want to go through the passages 1 through 4. That way you're not wasting time flipping between them because there's really a negligible difference between the different passages there. So go through the questions as you see them. Like I said, don't want to waste time flipping between question 10 and question 30 too much. You know, you just go through the questions as you see them. It helps you avoid having to reread text too. Try to answer all the questions in right around 25 to 30 minutes. That's going to leave you anywhere from 5 to 10 minutes then at the end to go back and check your work. So that'll be helpful as well. So that's going to be about 34, 41 seconds per question on average, leaving you 5 to 10 minutes, like I said. Final minutes, what you want to check, obviously first priority is going to be any questions you skipped that you left unanswered or were unsure of. After that, you're going to go make sure that your bubble sheet matches your booklet. If you're taking this pencil paper, if you're taking the SAT online, then obviously you don't have to worry about that. And then after that, you're just checking all the questions that you can. So start with the ones you're most unsure of, work the way to the ones you're most confident of. All right, now we got the SAT reading. So SAT reading section, let's talk pacing strategy for this one. You want to make sure that you're reading and making any annotations, which keep in mind your annotations should just be reserved to underlines, boxing, circling, things like that, so you don't have to stop reading. And you want to finish that initial read through in less than 4 minutes, ideally 3 to 3.5. You want to aim to answer all the questions on one passage in anywhere from 9 minutes to 11 minutes. That's going to leave you anywhere from 10 minutes to 20 minutes at the end to check your questions that you skipped over or were unsure of. And then you also want to make sure you're doing the passages in order that are easiest to you. So if you're better at science passages, make sure you're starting with the science passages. If you're better at literature passages, make sure you're starting with the literature passage. You want your weakest passage to be the one you do last. So answer the questions in the order they appear in each passage. So that means that, for example, if your passage is the first passage, don't start with question 5, start with question 1. Skip any questions you feel very unsure of after 30 seconds, write star them in your test booklet, then come back to them at the end when you have time. Once again, try not to skip more than 3 questions per passage, because if you're skipping more than 3 questions per passage, then it's going to cause inefficiency because you have to go back and forth between different passages. Coming back at the end and trying to answer too many questions at the end is going to be an issue as well. Okay, so if you read through a question a second time and you still don't know what it's asking though, skip it, come back to it at the end. So those are your guides for skipping questions, when to skip, how many you should try to, you don't want to skip more than 3 per passage, obviously. But yeah, that's your ideal strategy there. As far as things to check in the final minutes, once again, obviously first priority, any questions you haven't answered, you need to answer them. You want to answer every question on any part of the SAT because you don't get penalized for wrong answer choices. Any questions you're unsure of is the next priority after the ones you haven't answered. At that point, if you're taking SAT pencil paper, make sure that you make that your test booklet matches your bubble sheet. You don't want to be off by 1 and then have a whole series of the rest of your answers all off by 1 question. So you want to take about 1 minute to check that. It shouldn't take too long. And then after that, you're just checking as many questions as you can. So hopefully this pacing is helpful. I think that if you follow, it's going to be really beneficial. Particularly, try to make sure that you have this pacing of the math no calculator and with calculator sort of memorized or down so you understand how to use it, because it's going to help you maximize your scoring potential in the math sections. I think that's really helpful. Same thing with the reading section. As far as understanding, you want to start with your easiest passages. So try to decide what your best passages are today so you know tomorrow going into the SAT where to start for the reading section. So that takes care of the pacing for today. And with that, we're going to go through today to review for the SAT is going to be questions 22 to 31 of SAT Practice Test 5. So This passage is adopted from Brian Walsh. It's titled Whole Food Blues, Why Organic Agriculture May Not Be So Sustainable, copyright 2012 by Time Inc. When it comes to energy, everyone loves efficiency. Cutting energy waste is one of those goals that both sides of the political divide can agree upon, even if they sometimes diverge on how to best get there. Energy efficiency allows us to get more out of our given resources, which is good for the economy and mostly good for the environment as well. In an increasingly hot and crowded world, the only sustainable way to live is to get more out of less. Every environmentalist would agree. But change the conversation to food and suddenly efficiency doesn't look so good. Conventional industrial agriculture has become incredibly efficient on a simple land-to-food basis. Thanks to fertilizers, mechanization, and irrigation, each American farmer feeds over 155 people worldwide. Conventional farming gets more and more crop per square foot of cultivated land, over 170 bushels of corn in Iowa, for example, which can mean less territory it needs to be converted from wilderness to farmland. And since a third of the planet is already used for agriculture, destroying forests and other wild habitats along the way, anything that could help us produce more food on less land would seem to be good for the environment. Of course, that's not how most environmentalists regard their arugula, which is a leafy green. They have embraced organic food as better for the planet and healthier and tastier too than the stuff produced by agricultural corporations. Environmentalists disdain the enormous amounts of energy needed and waste created by conventional farming, while organic practices foregoing artificial fertilizers and chemical pesticides are considered far more sustainable. Sales of organic food rose 7.7% in 2010, up to 26.7 billion, and people are making those purchases for their consciences as much as their taste buds. Yet a new meta-analysis in Nature does the math and comes to a hard conclusion. Organic farming yields 25% less crops on average than conventional agriculture. More land is therefore needed to produce fewer crops, then that means organic farming may not be as good for the planet as we think. In the Nature analysis, scientists from McGill University in Montreal and the University of Minnesota performed an analysis of 66 studies comparing conventional and organic methods across 34 different crop species from fruits to grains to legumes. They found that organic farming delivered a lower yield for every type of crop, though the disparity varied widely. For rain-watered legume crops like beans or perennial crops like fruit trees, organic trailed conventional agriculture by just 5%, yet for major cereal crops like corn and wheat, as well as most vegetables, all of which provide the bulk of the world's calories, conventional agriculture outperformed organics by more than 25%. The main difference is nitrogen, the chemical key to plant growth. Conventional agriculture makes use of 171 million metric tons of synthetic fertilizer each year, and all that nitrogen enables much faster plant growth than the slow release of nitrogen from compost or cover crops used in organic farming. When we talk about a green revolution, we mean a nitrogen revolution, along with a lot of water. But not all the nitrogen used in conventional fertilizer ends up in crops. Much of it ends up in running off in the soil and into the oceans, creating vast polluted dead zones. We're already putting more nitrogen into the soil than the planet can stand over the long term, and conventional agriculture also depends heavily on chemical pesticides, which can have unintended side effects. What that means is that while conventional agriculture is more efficient, sometimes much more efficient than organic farming, there are trade-offs. So an ideal global agricultural system, in views of the study's authors, may borrow the best from both systems. As Jonathan Foley of the University of Minnesota explained, the bottom line, today's organic farming practices are probably best deployed in fruit and vegetable farms, where growing nutrition, not just bulk calories, is the primary goal, but for delivering sheer calories, especially in our staple crops of wheat, rice, maize, soybeans, and so on, conventional farms have the advantage right now. Looking forward, I think we'll need to deploy different kinds of practices, especially new mixed approaches that take the best of organic and conventional farming systems where they are best suited geographically, economically, and socially. All right, moving on. We're going to get into our questions now. Okay, so we got that done in under 4 minutes for the reading, which is perfectly fine. Now we've got, as used in line 14, simple most nearly means what? Well, let's go to line 14, see what simple most nearly means. Okay, we see in line 14, we have conventional industrial agriculture has become incredibly efficient on a simple land-to-food basis, or on a pure or straightforward land-to-food basis is what I'm looking at there. Okay, so we got simple, we don't have pure, but we do have straightforward, so that'll be our answer there. Not modest, not unadorned, and not easy. Okay, we need a meaning that says that it's only on that land-to-food basis. According to the passage, a significant attribute of conventional agriculture is its ability to do what? Well, let's look through our options here. Okay, we know that it talks about conventional agriculture being able to provide a lot of food on little land. Okay, so we're gonna find an answer choice that says that. Option A, produce a wide variety of fruits and vegetables. No. B, maximize the output of cultivated land. Yes, we talk about how we get a lot of crops per unit of land. Okay, C, satisfy dietary needs of world's population. No. Lessen the necessity of nitrogen. No. Moving on, 24. Which choice best reflects the perspective of environmentalists in line 27 on conventional agriculture? Obviously, they did not like it, right? And we see our next question is evidence, so I'll go and show you this as well. Okay, we see that they say, of course, most environmentalists regard their leafy greens embracing organic food as better for the planet, healthier, tastier than the stuff produced by agricultural corporations. They are against this modern agriculture. They are for organic, so against conventional, for organic. Okay, so their opinion on conventional agriculture then is not that it produces, or I'm sorry, it is that conventional agriculture produces inferior fruits and vegetables. Okay, they say it tastes worse, right? The conventional ones versus the organic. And they say that it's detrimental to the environment, right? Option B, it's energy efficient. Okay, they don't make that argument and reduces the need to convert wilderness to farmland. That's not their argument. Good for the environment only in the short run, not their argument. Depletes critical resources but protects wildlife habitats. Once again, not their argument because they don't argue that it protects wildlife habitats. They argue it's detrimental to the environment, produces inferior fruits and vegetables. Okay, that's going to be in those lines 28 to 31, I believe it was. We can go take a look real quick. It's where we talk about those leafy greens. Yep, it looks like that'll be 28 to 31. Okay, 28 to 31 will be our evidence there, as I pointed out before in 24. Okay, moving on, we got 26. Which statement best expresses a relationship between organic farming and conventional farming that's presented in the passage? Okay, we talk about pros and cons to each one, so let's find an answer choice that talks about that. Option A, we have both are equally sustainable. We don't make that claim. We see, I can go ahead and point it out to you really quick. Okay, we see that we don't make that claim because we say that it's more sustainable. Let's see if I can find it right here. Okay, I highlighted it right here, 35, line 35. Environmentalists view it as far more sustainable, the organic. Okay, so they're not that claim. Okay, we don't say they're equally sustainable. Option B, both rely on artificial chemicals for pest control. Organic doesn't, so B is wrong. C, both use nitrogen to encourage plant growth. True, but the nitrogen used in conventional farming comes from synthetic sources. Absolutely true. Answer there is going to be C. Okay, 100%. Which choice provides the evidence? Okay, right here we can use the keyword method. If you aren't familiar or forgot about the keyword method, if you're not sure where the lines are, which in this case you should because it's pretty obvious, but if you're not, what you use is you use a keyword from your answer in the previous question to figure out where to start. So in this case, I'd be looking at something talking about nitrogen, or I'd be looking at something talking about a comparison between conventional farming and organic farming. In this case, I don't have nitrogen in any options, so I'm going to look at something with conventional. I know I see conventional here and here. Here's the thing. I know that this is too early in the passage to be talking about nitrogen because I know nitrogen came later, so I'm going to start at part D. Okay, so I start at part D. I see that's line 61 to 65. We'll go there real quick. 61 to 65, we see it says the main difference is nitrogen. Chemical key to plant growth. Conventional agriculture makes use of synthetic fertilizer each year. And then we talk about how the nitrogen enables faster plant growth than the nitrogen coming from compost or cover crops in organic farming. Okay, so that's a difference as far as the nitrogen being synthetic in conventional farming versus organic. Okay, where was that at? Okay, we see that's line 61 to 65, so our answer there is going to be D. All right, moving on. Now we got question 28. According to Foley, an ideal global agricultural system does what? Well, it's going to take into account all of these factors in that farming, okay? So we're going to find an answer choice that says that. Option A, focus primarily on yield percentages in global markets. No. B, considers multiple factors in the selection of farming techniques. Yes, we talked about considering things economically, socially, as well as agriculturally. So our answer there would be B. Option C, weighs economic interests of farmers against consumers. No. Puts nutritional value first. No. Okay, option 29, we've got in line 88, shear most nearly means what? Well, let's go find our answer by going to line 88, looking at what shear means in the context of the passage. We see we have, let's see, where is it? Okay, right here. Go and circle it in black. We've got, but for delivering sheer calories, especially in our staple crops of wheat, rice, maize, corn, and so on, conventional farms have the advantage right now. Okay, that's pure calories there. We're talking only about calories. So I'd be looking for something that says that it's clearly only calories. So something like pure calories, something like that. Not transparent. Okay, that'd be see-through, not abrupt. We can't describe calories as abrupt or steep. Those two are going to be wrong. Our answer there is going to be pure, which is answer choice D. Moving on, we got 30. Which statement is best supported by the information in figure 1? In this case, I'm going to take a quick look at figure 1, see if I can find any patterns or broad things I can apply. Okay, I see that I've got really no trends I can apply since these are all just different categories, in which case I got to go through answer choices A through D. Okay, I just got to go through A through D, find which one's right. Okay, option A, organic yield as a percentage of conventional yield is greater for vegetables than for fruits. Let's go ahead and take a look. Vegetables versus fruits. Okay, figure 1. We've got vegetables as our circles, fruits as our darker circles. We see fruits is higher than vegetables. A is incorrect. Option B. Okay, option B. The organic yield as a percentage of conventional yield is similar for cereals and all crops. Let's take a look at that. Cereals versus all crops. We know cereals are going to be our shaded in squares. All crops are going to be our really, really dark circles. We see that those are very similar. So our answer there is going to be B for number 30. All right, moving on. Now we've got question 31. Which of the following claims is supported by figure 2? Okay, so let's just take a quick look at figure 2, see if there's any broad trends that we can immediately recognize. We have organic yield as a function or as a percentage of conventional yield. Obviously, we see that organic yield for every species is less than this 100%, which would be if they were equal. So we know organic yield's less than conventional. That's the big theme there. See if we have an answer choice that relates to that. So we have option A of the organically grown species represented. Soybeans have the lowest yield. That's possible. We're going to check that one later if we don't see our big theme show up here. Option B, the organically grown maize and barley represent are comparable in their yields to conventionally grown maize and barley. Once again, could be true. I'll check that if we don't see our big theme from our graph. Option C, of the organically grown species represented, tomatoes have the highest yield. Option D, the organically grown species represented have lower yields than their conventionally grown counterparts do. Yes, we saw all of the organically grown species were less than 100% as a function of their conventionally grown counterparts, thus they have lower yields. So our answer is going to be D for number 31. All right, hopefully this was helpful. As you can see, we got that done in under 11 minutes. So we're following that pacing, which is good because this is the day before your practice test. We want to make sure that you're comfortable with your pacing. You're able to see kind of what to look for and things like that. So with that, let's go and switch over to our next part of today's video. So that concludes the SAT reading passage. Now let's go and get started with grammar rules. I'll try to get through all of these in right around 15 minutes. So keep in mind it's going to be a little bit quick, so try to pay close attention. So let's go ahead and get started. So grammar rules. First one we're going to talk about is agreement between subjects and verbs in number. Okay, so if we have a singular noun, we need to have a singular verb. For example, if we have Joseph, we must have jumps, okay, because we need the singular jumps verb to match the singular subject Joseph. If we have Joe and John, we have to have jump, okay, because that's maintaining that plural number. Now keep in mind a way you can test this is with the he and they method, right? So if we say he, we would say he runs, which means we have an S there. If we're going to have a plural verb and we didn't know what the plural verb was, we know plural noun is they, we would say they run, thus run is the plural verb. Okay, so that's a trick you can use as he and they. Now, watch out for collective nouns. Collective nouns refer to a collection of individuals or singular subjects, and they group them into one singular subject. An example is Congress. We would say Congress is going to dismiss. Okay, Congress there is acting singular as a collective noun, so it needs a singular verb is. Okay, don't let prepositional phrases fool you. Okay, prepositional phrases, what do they look like? Okay, examples would be of clarinet players. That's prepositional phrase. We ignore prepositional phrases when determining the number of our subject and number of our verb. Another prepositional phrase would be with the most basketball players. Okay, we ignore that. So we would have group, which we know is singular, and then we would have is, okay? Group acting there as a collective noun as well. Okay, if we were to say the band, once again, acting as a collective noun is singular, and the band is very loud. So once again, we need that singular verb there, okay? So watch out for prepositional phrases, watch out for collective nouns. Pronouns, examples, he, she, they, that, those. Okay, those are going to be pronouns. Rules, it has to be clear who or what the pronoun's referring to. The number of the pronoun must agree with its subject. So, examples, we have John is a fast runner, okay? John obviously is the subject here. Then our pronoun would be he goes on a long run every day, okay? That right there, we have singular and singular, okay? Also matching gender there as well. Jason and John, that's plural, okay? We would also have to have they as our pronoun there, also plural. An incorrect example would be Jason and Joe run every day and he gets tired a lot. We don't know who he is. Is it Jason or is it Joe? It's unclear who's being referred to, therefore that one is wrong. Okay, now let's talk about another incorrect example. We have the computers of students in Poland are newer than that of students in New York. Okay, here's what's wrong with that. The computers of students in Poland, we know computers here is plural. Okay, of students in Poland, we ignore because it's a prepositional phrase, are newer than blank of students in New York. Once again, ignore the prepositional phrase. We need to have plural here. That's singular. We need plural, therefore we'd have to have those. Okay, so once again, making sure we're matching those numbers. All right, correct example, obviously computers of students in Poland are newer than those of students in New York. Another thing here, making sure that we're comparing things with the same number, right? Comparing things properly. That's another thing we need to watch out for on the writing section. Types of sentences, you've got your simple sentence, they have one subject, one verb. Compound sentence, two subjects, two verbs. Compound complex, two independent clauses and one independent clause, at least one independent clause. We're not going to spend too much time on that today. That was more for explaining other concepts, which we're going to go on to talk about now. So comma splices, right? You need to know this for the SAT writing section. Comma splices, they're basically run-on sentences, right? You use a comma where you would need to have a comma and a fanboy, right? The fanboys are for and nor, but, or, so, and yet. Those are your fanboys. So you can use a comma and a fanboy to connect two independent clauses. You can also use a semicolon. Okay, so a comma splice is where you don't use either of those. You only have a comma with no fanboy for two independent clauses, and that's incorrect. All right, moving on, we've got modifiers. Let's talk about modifiers. So they modify subjects and other words to give a better description or a more in-depth description. Keep in mind with modifiers, they have to be placed directly next to what they modify. That's the key part with modifiers. So let's go over an example. A correct example would be the world's brightest mathematician, comma, Jim Simons is a genius. You see how it's directly next to who it's modifying. Okay, it's modifying Jim Simons. Since in this case it's an introductory modifier, we have a comma after it. Now, what if we said Jim Simons, comma, the world's brightest mathematician is a genius? Once again, the modifier here would be the world's brightest mathematician. We offset it with commas to describe Jim Simons, which comes right next to it, in before it, right? So that one also is correct. An incorrect example would be Jim Simons is a genius, comma, the world's brightest mathematician. We see that there is a gap between our subject and our modifier, thus that is incorrect. We would have to rephrase that saying the world's brightest mathematician, comma, Jim Simons, or this other option here. So either of those first two would be correct, last one there would be incorrect. All right, let's talk about context. So words in the passage must make sense based on the context in which they appear. That means you need to read the passage to understand that context. Obviously, this type of passage reading differs from the way you read the reading section. I talked about that today already. Now let's go ahead and get into, we're going to skip the examples because like I said, today we're just trying to review common homophones. It might be a good idea. Hopefully, when I talked about this on, I believe it was day 2 or day 1, you went through, you found the ones you knew, didn't know, and looked those up. If you haven't yet, you should probably go look those up. But let's go ahead and keep reviewing, okay? Because I'm not going to take time to go through all of those. Hopefully you already did that. Parallelism, like I said, these should be easy points for you. You shouldn't have to worry too much about it. Just make sure you're paying attention for it. If you pay attention for it, these should be easy points for you to get. So parallelism, you want to pay attention to verb tenses, order of nouns, adjectives, and the verbs. They have to remain the same or parallel between two different phrases, right? Noun phrases have to be parallel. An example, Haley likes to run, jump, and swim. We have to have that same tense of the verb in run, jump, and swim. Same thing, Haley enjoys running, jumping, and swimming. Have to have that same ending there, right? Same tense. Another example, Jason likes riding his bike, reading his book, and driving his car. We have a verb, and then we have a possessive pronoun, and then we have an object in all three of those phrases there. Okay, so we want to pay attention to parallelism. Anytime that we see a series or a list or anything like that, we want to look for parallelism in that. Okay, so any answer choice that contains a list that includes verbs, especially if you have a list that includes verbs, it's potentially a parallelism question, and it probably is, so you need to make sure you look for parallelism actively. Correlative conjunctions. These are used to connect words that are equally important to a sentence's meaning. Example would be the car I bought was both fast and small. Okay, the correlative conjunctions there are both and. Okay, we have a list here. We have both and, either or, just as, so, neither nor, not only but also, at once and, no sooner than, if then, rather than. Okay, so those are some examples of correlative conjunctions. Go ahead and take a look over that. I'll give you about 10 seconds. Okay, now let's go ahead and keep going. So, being concise, right? This is huge on the SAT writing section. I can't stress this enough. Be concise in word choice, be efficient in word choice, never repeat things unnecessarily, and avoid redundancy at all costs. If you can avoid redundancy and repetition on the SAT writing section, you will do so much better, okay? You gotta avoid redundancy and repetition on the SAT writing section. Don't repeat information that has already been said, okay? Use modifiers to avoid repeating the same word twice. If you have one word at the end of a sentence and one word at the beginning of the sentence, one strategy you can use, you're going to be asked to combine the sentences more than likely. Get rid of the one starting a sentence, right? So let's say we have a word here. We'll say it was Joe Jones, right? And Joe Jones ended this sentence right here. Joe Jones. Okay, and you're asked to combine these sentences, right? It's underlined. Then what you want to do is you want to look to get rid of this part right here, put a comma here, and put the word who, okay? So keep in mind that applies to places and other subjects as well. So anytime I see I have that situation where I have the same thing ending one sentence and starting the other, and I'm asked to combine them, what I'm going to look to do is put a comma where the period is, get rid of whatever was right there as far as the thing that was repeated, and use who or what or when or where, okay, in order to get rid of repeating that word. Okay, so that's one strategy I'll use as well. But either way, just make sure you're avoiding repetition and redundancy. You want to make sure you do that. Don't be redundant. Use good diction. Have a precise word choice. Don't repeat things. Okay, if you see something such as annually and every year, make sure you get rid of one of those. All right, idioms. So idioms questions, right? The strategy here is basically what would you naturally say, especially if you're someone who spoke English their whole life and you're really, really comfortable with it. That's what you want to do, is you just want to think, what would you naturally say, okay? So some examples from practice tests are wait for, serve as a means of, and in order to be. Right? If you want to look up some common SAT idioms, it'd be a good idea, especially the day before the SAT, which is obviously today. Especially if you're someone who English isn't their first language, I would definitely recommend looking up some common SAT idioms before you take your test tomorrow. Just look over them for like 5 minutes if you can. I think it'd be helpful. All right, next up, let's keep moving. So we've got colons, em dashes, and apostrophes are what we're going to talk about now. So colons, they have to have an independent clause before it. We know an independent clause is a subject and a verb. What comes after a colon gives examples, explains, or illustrates what came before it. So some functions of a colon. It can be used to introduce a list. It can be used to connect two independent clauses, but only when the second independent clause is illustrating or explaining the idea in the first. Okay, another reason we can use a colon is for emphasis. So in that case, it's similar to an em dash, but we would usually prefer an em dash for emphasis. So that's just one thing to note, but a colon can be used for it. Okay, so let's talk about the em dash now. Em dash, its three main purposes are what? Well, its three main purposes are indicating non-essential information, right? So we know with non-essential information, we can take it out of the sentence and the sentence would still be a full sentence on its own, right? It would be an independent clause. It makes perfect sense. So we can remove the information that's non-essential. Now, the non-essential information we can remove has to be set off with either em dashes, comma, or parentheses. Those are our three options, okay? So you can use an em dash to do that, or commas, or parentheses. Okay, what about an em dash for emphasis? Okay, you can use an em dash for emphasis as well. We could say there is only one Los Angeles Lakers player to trust with the last shot, em dash Kobe Bryant. Okay, you can also use an em dash for abrupt changes in thought. So for example, if I said I should write an essay on Thanksgiving, no, on business ethics. That's an abrupt change in thought. We use that em dash there. Okay, now let's talk about apostrophes. So apostrophes, you can have possessives. For example, John's car. Obviously, anytime that someone owns something, you want to use that apostrophe. Now, what if we had a plural subject? For example, the Lakers, the basketball team, right? We've got the Lakers, it is their court. Okay, Lakers has that S there, so we want to put that apostrophe after that S then, since it's their court. Contractions, obviously we have contractions where we have to use an apostrophe as well, such as it is or they are when we use their. And then we got parentheses. Parentheses are used for non-essential information like I already talked about. So if you can take it out and the sentence still makes sense, then obviously it's going to be non-essential and you should put parentheses, commas, or em dashes to set it off. Keep in mind you can't mix them up. You can't use a parentheses and an em dash. If you're going to use parentheses, it's got to be parentheses on both sides. If you're going to use an em dash, it's got to be em dash on both sides. Comma's got to be a comma on both sides as well. Okay, some random other stuff that you should know. So avoid casual language on the SAT writing section. Try to maintain an academic tone. Avoid slang as well. Understand relationships between ideas. So a lot of times you'll be asked to put in a transition word at the beginning of the sentence. If you see one word at the beginning of a sentence with a comma after it and it's underlined, make sure that you understand you're looking to transition between the previous sentence or paragraph to your next sentence. Okay, so understand that. So what you want to do then is you want to skip reading over that underlined word and read your next sentence that you have to connect to that previous sentence, figure out how they're related, and then use that to understand which transition word you want to pick. So for example, if you want to contrast, you'd use a word like in contrast with a comma after it, or however with a comma after it. If you were looking at similarities, you could use not unlike. Yes, that was a correct answer on a practice test for showing something that was similar. You could also use the word like. For differences, you could use unlike. For digressions, right, for something like I digress or something like that, you could say nevertheless. Some contradictions, right? So you could say, well, someone argued for this bill. He did not fulfill his constitutional duty. So with a contradiction, if you're going to use the word well, understand you don't put the comma after well like that. You would put it after the phrase, right? So the phrase here would be, well, Johnson argued for the bill, comma, right? And if you see that at the beginning of the sentence, if you see you have when, well, or any other subordinating conjunction or because at the beginning of a sentence, if you see you have any words like those at the beginning of the sentence, you have to have a comma at the end of that dependent clause. Okay, so understand that. All right, emphasis. So if you're looking at a transition to be emphasizing something, you could use furthermore or moreover. Those are two good ones. And like I said, correct relationships trumps awkwardness, such as in not unlike on that question on the practice test, you had to show that the two sentences were expressing similarities, and the only option was not unlike. All the other options express differences. So even though normally we would say like instead of not unlike, we got to understand that the correct relationship between sentences would trump any awkwardness like that. Okay. All right, such as, let's talk about such as. So if such as is, if we want to place a comma before such as and after each item in a list if such as is non-restrictive. Okay, if it's non-restrictive, then we want to have a comma before such as. So if we take a look at our example here, there are lots of types of fruits, comma, such as apples, oranges, and bananas. Are there more fruits than that? Yes. Thus it is non-restrictive. It's not restricted to just those three fruits. Thus we put a comma before such as. Another way you can tell it's non-restrictive is if you ignored all of this, if the sentence still makes sense, because then it'd be there are a lot of types of fruits, period. That still makes sense. Now, as far as restrictive ones, okay, some restrictive ones would be this. Let's say we said sports such as baseball and football involve a ball. How do we know it's restrictive? Well, there are more sports, or I'm sorry, how do we know that it's restrictive? We know that it's restrictive because there are sports that don't involve a ball. Okay, so in this case, we are restricting the sports to just baseball and football because there are sports that don't involve a ball, like track and field, swimming and diving. So if we were to take out such as baseball and football, we would have sports involve a ball, which is a false statement since there are sports that don't involve a ball. So that would be an indication of a restrictive one. Okay, dependent clauses and subjects. Okay, so this one's good. So this one right here is probably going to show up not that often on the SAT writing section, but we'll quick touch on it anyways. So dependent clauses acting as the subject of a sentence. That can happen. For example, the fact that the New York Knicks have not won a championship in 10 years is extremely disappointing to me. In this case, the prepositional phrase that the New York Knicks have not won a championship in 10 years can be ignored when determining the number of our subject and our verb, and we would go back to the fact, which we know is singular, thus our verb would have to be singular. So understand that it can act as the subject of a sentence. A dependent clause can. Okay, who versus whom and who versus that. This is the last thing we're going to talk about for the grammar rules today. All right, so the key thing that you need to know is the trick with it. So the trick is this. If I works in place of the pronoun, then who should be used. If me works in place of the pronoun, then whom should be used. That's the key thing you need to understand here. So an example, all of the students who are able to jump 25 inches will receive an A in the class. Okay, in this case we would take out who, in this case we could say I am able to jump 25 inches. Since we use I there, we use who. Another example, all of the students whom teachers despise will receive an F. Okay, in this case, what if we said teachers despise me? Okay, since we would use me there, we want to use whom. Okay, so that's your indication. We wouldn't say teachers despise I, we would say teachers despise me, thus we would use whom. Okay, so that's going to be your trick there for understanding when to use who versus whom. Who is the pronoun that is used for people or a person, and that is the pronoun that's used for anything that's not a person or people. Okay, all right, so that covers our grammar rules. Now let's go ahead and do a practice writing passage as our next step in today's lesson. All right, so let's go ahead and do a practice passage for today. So we've got questions are from SAT Practice Test 5. We're going to do this passage right here. So it's going to be questions 12 through 22, SAT Practice Test 5. So we have Thomas Nast, the crusading cartoonist. Stop Them Pictures. Legend has it that the corrupt politician William Boss Tweed once used those words when ordering someone to offer a bribe to Thomas Nast, an artist who had been famous for cartoons that called for reforms to end corruption. Okay, here I see I have words beginning of sentence followed by a comma, looking to transition previous sentence to next sentence. Next sentence says Tweed's attempt to silence the artist failed, and Nast cartoons published in magazines like Harper's Weekly actually played a key role in bringing Boss Tweed and his cronies to justice. All right, what do I see there? Well, I see that that's not as a result of what came before, so I can't use A. I see that it's not causal, so I can't use therefore. And I see that it's not really emphasizing what came before and continuing on, so I can't use furthermore. So my answer there, I'm just going to delete the underlined portion for number 12. Okay, 13. I've got combining these sentences. So let's take a look. We want to be efficient in word choice. We have powerful political organizations in the 1860s and 1870s started taking control of city governments, and they were known as political machines. Because I see I have comma and they were known as, that's wordy and inefficient. I don't want to use that. Another thing here is I should have started with my shortest answer choice. When I'm asked to do questions where I have to combine sentences, I should start with my shortest answer choice and then work to my longer ones. Okay, so I made a mistake there. I shouldn't have started with A. Obviously, I see A is wrong. I should always start with my shortest sentence when I have to combine them like this, because that's the one that's most likely to be efficient in word choice. We have in the 1860s and 1870s, powerful political organizations known as political machines started taking control of city governments. Yes, that's perfect, right? It's very concise in word choice, very efficient. Answer there is going to be D for number 13. All right, looking on, we've got question 14. These political machines were able to pack legislatures and courts with hand-picked supporters by purchasing votes, comma, a form of election fraud involving the exchange of money or favors for votes. Okay, that's perfect right there. Very efficient word choice, very concise, good diction. Answer there is going to be A. We don't want to add being, don't want to add that is, and don't want to add which it is, because those are all unnecessary and they're just really, really inefficient. Okay, unnecessary. I don't even know how to I think I do know how to spell it, but I don't need to. Okay, it's going to be unnecessary. Okay, all three of those would be. We don't want to add on. We want to be efficient and concise. Answer for 14 will be A. Moving on, we've got once a political machine had control of enough important positions, its members were able to use public funds to enrich themselves and their friends. Boss Tweed's Tammany Hall Group, which controlled New York City in the 1860s. Okay, key thing here is I see I have a non-essential phrase or clause, because I could take out all the way from which to 1860s and still have a full sentence. I would have Boss Tweed's Tammany Hall Group stole more than 30 million. Okay, so I see I have a comma comma there at the start of my non-essential, thus I have to have a comma after 1860s. Okay, I don't need a comma after city, so I know C is wrong. I know D is wrong because it doesn't have that comma after. I know A is wrong because it uses an M dash, and so there's going to be B for 15. Moving on. All right, we've got the equivalent of more than $365 million today. We're asked if we should keep or delete the sentence. Let's see what it says. We have Tweed had been elected to a single 2-year term in Congress in 1852. What does my next sentence say? Tammany Hall was so powerful and corrupt that I don't need a comma after that. Okay, I don't need a comma after that. Don't need a comma before that. A and B are wrong. Option C is going to be correct because we see after commented we have a quotation, so we need to have a comma after the word commented since we do have a quotation after it. Okay, I don't need a comma here either, so answer there is going to be C for 17. In the city, which is there's nothing beyond the reach of the insatiable gang. Okay, saying that he had been elected to a single 2-year term in Congress in 1852. At that point, it's really blurring our focus. We don't want to keep it. We want to get rid of it. Okay, it doesn't undermine our claim of the passage, so that's not why we want to delete it. We want to delete it because it's blurring our focus by introducing a loosely related detail. Okay, answer there is going to be C for 16. 17 is going to be answer choice C. Moving on, we got questions 18 and 19. Given the extent of Tweed's power, it's remarkable a single cartoonist could have played such a significant role in bringing about his downfall. NAS cartoons depict Tweed as a great, big, bloated thief. One of the artist's most famous images. Okay, saying famous and well-known, same thing. Same with commonly known. We don't want to say the same thing twice, which is what we're doing in B, C, and D. Answer there is going to be A. Okay, we want to avoid repetition and redundancy at all costs on the SAT writing section. Answer for 18 will be A as a result of that, or as a result of these all being repetitive and redundant. Okay. All right, moving on. We've got images showed Tweed with a bag of money in place of his head, which adds the most relevant supporting information to the paragraph. Let's go ahead and look through. We want something that is showing that he's greedy, right? That's why they're putting the bag of money as his head. Option A, like many other NAS cartoons, that one was published in Harper's Weekly. That's not really adding on to our passage, anything that's really important or supporting our points. Option B, NAS would later illustrate Tweed's escape from prison. Once again, not showing Tweed's greedy nature and the fact that we want that money as his head to show that. Option C, one depiction that omits his signature hat. That's really irrelevant and not helping support our paragraph. D is going to be our answer then. We have an image that perfectly captures his greedy nature, thus showing the Tammany Hall group as greedy and Tweed as their leader as greedy. And so there's going to be D for 19. We've got another feature on a featured Tweed leaning against a ballot box with the caption, "As long as I count the votes, what are you going to do about it?" These cartoons were so effective in part because many of the citizens who supported Tweed were illiterate and thus could not read the newspaper accounts of his criminal activities. NAS cartoons, though, widely exposed the public to the injustice of Tweed's political machine. Moving on, we've got NAS campaign to bring down Tweed and the Tammany Hall group was ultimately successful. In the elections of 1871, the public voted against most of the Tammany Hall candidates, greatly weakening Tweed's power. Eventually, Tweed and his gang were persecuted, no, prosecuted on a number of charges, okay? This one right here is a homophone question. It needs to be prosecuted. He was prosecuted on a number of charges, including fraud, larceny. Many of them were sent to jail. 1875, he escaped from jail and fled to Spain and unwittingly brought about one final. Okay, I know that it's going to be brought since I see I have fled. That's past tense. Then brought. He fled to Spain and he brought about one final. So we need to maintain that past tense. Only option that's doing that. We don't need has brought. Okay, that's wrong. Answer there is just going to be brought. Answer is going to be A for 21. One final pinnacle for the power of political cartoons. Well, no. Let's see what it says. We have a Spanish police officer recognized Tweed from one of NAS cartoons. As a result, they sent Tweed back to jail. NAS was hailed as the man who toppled the great Tammany Hall machine. Okay, that's not a pinnacle for the power of political cartoons. It's a triumph, right? Because they won. They brought him back to jail. Okay. And they ended the Tammany Hall group. So that is a triumph, okay? Not a culmination, not an apex, but a triumph. So our answer there is B. All right, so as you can see, we finished that one right around 6 minutes, which is obviously fantastic on time. If we did every passage in 6 minutes, we'd finish with 11 minutes left, which would be fantastic as far as pacing goes. So pacing was good there. So yeah, hopefully that one was helpful as far as prepping you just to be comfortable, prepared, understanding good pacing for the SAT writing section, right? Obviously you could have gone a little bit slower and still been fine on this passage, but hopefully that was comfortable for you. Hopefully you learned a little bit, had a good job reviewing, and let's go ahead and move on to our next part of today's video. All right, so let's go through the math formulas and equations you need to know for the SAT. So I'll be moving a bit quicker through this one since it is the day before the SAT and we're just kind of reviewing them. So let's go ahead and get started. Slope-intercept form, obviously that's going to be y equals mx plus b, slope being m, y-intercept being whatever your b value is. If it was minus a number, then obviously your y-intercept would be negative. Vertex form, that's going to be for an equation that's set up such as 9x squared plus 2x plus 1. Right, that would be an example of an equation, and that equation, if it was in vertex form, would look something like this. Y equals a times the quantity x minus j squared plus h, where your vertex then is going to be at j and h, okay? Understand that your vertex would be at j and h, so pay attention to that minus sign there, that's important. Distance formula, that's going to be equal to the square root of your rise squared plus your run squared, or in other words, the x your second x coordinate minus your first x coordinate, that value squared, plus the difference between your second y coordinate and your first y coordinate squared. And then that's all obviously square rooted. Quadratic formula, right? A couple of things here. We'll cover the quadratic formula, and then we'll also cover the remainder theorem here as well. Quadratic formula is going to be x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Another example here we could use, that's for a parabola such as 9x squared plus 2x plus 1. That could be an example of the parabola. In that case, your a value is going to be 9, your b value would be 2, c value would be 1. All right, now let's go ahead and talk about, we'll get to the remainder theorem in 1 minute here. Let's talk about b squared minus 4ac. Okay, if b squared minus 4ac is greater than 0, you're going to have two real solutions, such as in this graph right here, which I'll put in red, right? I'll go ahead and square it in red. Okay, such as in this graph, that's your example for this one here. Next one, if your b squared minus 4ac value is equal to 0, you're going to have one real solution, such as in this graph that I'm squaring in blue. Now, what if your b squared minus 4ac value is less than 0? Then there's going to be no real solution, such as the graph in black. All right, now we've got our remainder theorem. Okay, our remainder theorem. Let's say that we have this top equation divided by x minus 2. So I'll go ahead and put this in red so you see what I'm talking about. Okay, we're dividing it by x minus 2. What you're going to do then, since you have x minus 2, is you take that 2 then, and you're going to plug it in for your x value in your numerator, right? So you do 2 then times 2 to the cubed, right? 2 to the third power, since that's what your x is, minus 5 times 2 squared, and then plus 4 times 2, and then plus that 3. Now, in this case, we know that that's going to equal 7. Thus, our remainder at the end has to be plus 7 over x minus 2. So you might end up with a couple options, right? A, B, C, and D. All right, A, B, C, D. Okay, and then you've got, they have a similar first part, but then at the end, they all have different remainders. You can find your answer just by solving for the remainder, thus saving you time. That's why the remainder theorem is important, because it'll save you time. All right, exponents. Okay, let's cover exponents. If we have the same base, right, for example, x, and we're dividing, we're going to subtract. Okay, so that's this top example. I'll go ahead and square that one. So, example, we have x to the 22nd power over x to the 14th. That's the same as x to the power of the difference between 22 and 14, which is x to the 8th. Okay, if we have x to the third times x to the fourth, we're going to add those. So if we have the same base, then we can go ahead and add our exponents to get x to the 7th in this case. Now, what if we have a number to a power, right? As an example right here that I'll box up in blue, we have x to the third to the fourth power. In that case, you are multiplying, right? So you're going to have x to the power of 3 times 4, which will equal x to the 12th. Okay, next one. Let's say that we have x to the power of a negative exponent with a fraction, right? Also with fractions as exponents. Well, the negative means that you're going to have 1 over x to the power if it were positive. So in this case, you'd have 1 over x to the 1/2. X to the 1/2 means that you have the square root of x, right? So whatever your fraction is, let's say, for example, it's 2/3. If we have x to the 2/3, then what that means is we're going to have the third root of x squared. So the denominator of your fraction of your exponent is going to be whatever that root is, and the numerator is what is going to be the exponent of the variable inside of that root. Okay, the negative means that obviously it's going to be 1 over whatever it is, as shown in this example here of this x to the power of -2. That would be 1 over x squared. All right, so that's exponents. Now let's talk about some tricks we can use to save time. So the sum of perfect squares. If we have x plus j squared, I'll use blue here. Okay, if we have x plus j squared, we know that that's going to equal x squared plus 2xj plus j squared, right? We could rewrite that as x plus y squared as well. Okay, let's say that we have x plus y squared. We know that that's going to equal x squared plus 2xy plus y squared, right? Next up, we have the x minus j squared. Keep in mind that the variables are interchangeable, right? So it could be x minus y squared, whatever, same thing. You're going to have x squared minus 2x times j plus j squared. Once again, you can do the same thing with y's, right? X minus y squared. You're going to end up with then x squared and then minus 2xy, and then you're going to have a plus y squared as well there. So the only thing that changes is the sign of that middle term. All right, next up, we got the difference of perfect squares. So let's say we have x minus j times x plus j. We know that our middle term is going to cancel there, and we're going to have x squared minus j squared. So pay attention, once again, that could be written with y as well, right? So just pay attention to the fact that that middle term is going to cancel out, and you're also going to have that minus sign right there. All right, next up, we can also deal with this with imaginary numbers. Let's say we have h plus zi times h minus zi. Then what that means is that we know I squared is equal to -1. Thus, what we're going to have here is we're going to have h squared plus z squared. So how does that work? Well, this plus zi is going to get multiplied by this minus zi, and that's going to end up giving us minus z squared I squared, which we know I squared is -1, thus it changes that sign up front to a positive. Okay, and the middle term is going to cancel just like in the difference of perfect squares. So we'd have h squared plus z squared. All right, next up, let's talk exponential growth and decay. So the equation for exponential growth and decay is going to be y equals your starting amount times 1 plus or minus your growth or decay rate to the power of t, which is generally years. All right, so we've got, but they'll tell you what it is. So it's not always years. Pay attention. It could be a different variable, but they'll tell you what it is. All right, so let's say that we are decreasing by 50%. That's our rate. And let's say we start with 500. Then our equation would be y equals 500, 1 minus 0.5 squared. If we were doing it for 2 years, okay? So that's if we were doing it for 2 years. All right, next up, we've got the average and the mean, okay? Average and mean. So average is going to be the sum of all your terms divided by the number of terms. Your median is going to be your middle term, so you're just going to get rid of your low value, get rid of your high value, get rid of your next lowest, get rid of your next highest, get your median. Also, if you end up with a median where you have two numbers like this, in that case, what you're going to do is you're going to find the average of those two, and that'll be your median. So in this case, it would be 10. Okay, mode, that's the number that shows up most often in a set of data. So if this was our set of data right here, we know that our mode then would be 7 since it shows up more than any other number. Standard of deviation, all you really need to know, you don't need to know the equation, you just kind of got to be able to tell from a graph. So for example, the standard of deviation in this case of graph 2 is going to be greater than graph 1 because we see that we have an average right around, looks like right around 9 here, but we see that we have a lot more deviation from 9. We go all the way over to 2, all the way over to 15, and we still have 2 points there, whereas over here with this average of 9, we are very, very concentrated around it, right? We see that as we go away from it, there are much, much less points. All right, and we also see that we've got financial models, okay, so some interest equations. We have simple interest, okay? Simple interest in this case is going to be your amount owed is going to equal your initial amount of your loan times your rate times time. Now keep in mind, if it's your total amount owed, you have to have that 1 there, okay? So if your rate was 5%, you'd have to have 1.05 if you're calculating your total amount owed. If you're calculating the amount of interest that has been added onto what you're owed, okay, then you would put a 0 there in front, so it'd be 0.05. So keep that in mind as well. All right, next up, compound interest. Your equation for that is going to be your total amount owed is going to equal your initial amount that you took out in your loan times 1 plus your interest rate over the number of times it's compounded per unit t, all raised to the power of the number of times it's compounded times t. Okay, so this one right here is probably one of the more difficult equations and formulas you need to know for the SAT math section. Keep in mind n is the number of times it's compounded per unit t. That's really important to understand here. Okay, so for example, the total amount owed if you took out an initial loan of $1,000 and you had your interest rate of 5% and you compounded it quarterly, which is 4 times per year, and you did this for 2 years, then you would have your n is 4 and your t would be 2 years. Okay, so that would be your equation there. All right, statistics. Let's talk statistics. So bias sampling. If you have a bias sample, you can't come to an accurate conclusion about your data. If you have a sample and you want it to be not biased, you better have random sampling. If you have random sampling, it's not likely that you're going to have a biased sample. You also should have random assignment, which means that you're not picking one trait and only giving people with that one trait, for example, a certain medicine and giving other people no medicine. You want to randomly assign all of the patients or treatment or groups. You want to assign that randomly, the treatments to them. All right, geometry and trigonometry. Keep in mind, random assignment doesn't really show up that much on the SAT. It's more bias sampling and random sampling that you need to understand. Random assignment, that's more AP stats, but it could show up. That's why I explained it right there. Okay, geometry and trigonometry. So we got SOHCAHTOA, right? Obviously, we got sine, cosine, and tangent. So we've got our example triangle on our right here. We've got Z, J, and Q as our side lengths. We got angle X. The sine of X is obviously going to be our opposite over our hypotenuse. So we look at our opposite. We see that our opposite is going to be Q, and we see our hypotenuse is going to be J. Thus, the sine of X is going to be Q over J. Cosine of X, we know that that's Ka and SOHCAHTOA, so that's going to be our adjacent over our hypotenuse. Our adjacent obviously is going to be Z, hypotenuse J, Z over J. Tangent is going to be TOA, which is going to be our opposite over our adjacent. We see that our opposite is going to be Q and our adjacent is going to be Z, thus we're going to have Q over Z. Okay, next thing we need to understand, Pythagorean theorem, a squared plus b squared equals c squared. In this case, our hypotenuse is 10. We see that we have a side length of 8, and we wanted to solve for x. Thus, we're going to do 10 squared as our c squared, since c is our hypotenuse. Side length is 8, so we do 100 there, minus 64 after we square each one. And we're going to be left with 36 equals x squared. Square root each side, we get x is 6. Some triangles that you should know to save time on the SAT are going to be the 3, 4, 5 triangle. If you have 3 as one side length, 4 as another side length, and it's a right triangle, you're going to have 5 as your hypotenuse. If you have a 5, 12, 13, let's say you have 13 as your hypotenuse, let's say you have 12 as a side length, your other side length must be 5. If you understand those, you're going to save some time on the SAT math section. Another equation you can use to save time is the fact that for an equilateral triangle, keep in mind an equilateral triangle is one where all the sides are the same length and all angles are going to be 60. Your equation for the area of it can be given by the area is equal to the square root of 3 times the side squared. Keep in mind all the sides are the same, so if you have 1, you have it, all over 4. Okay, if you can memorize that one, you could save time. I don't think that one is on the reference sheet, so if you can memorize that one, it'll save you time. Circles. Let's talk circles. The equation for a circle, x minus h squared plus y minus k squared equals r squared, where r is your radius. Your center is going to be at hk. Keep in mind we have this minus sign, right? So if we have x minus a number, then our center is going to be that number without that minus sign. If we have y minus a number, our center is going to be that number without that minus sign. What if we have y plus a number? If we have y plus a number, then we have to take the minus of that number in order to get our center. All right, moving on. Obviously, we've got our example there. Let's say we have x plus 3 squared plus y plus 2 squared. Obviously, we have to flip the sign since it's adding there, so our center would be -3 and -2 since we got to flip that sign. Okay, and then obviously our radius is going to be squared, so keep in mind, always pay attention to that fact that you have your radius squared. Make sure you square it. Okay, 360 degrees is equal to 2 pi radians. Let's say we're given given some measurement in degrees and we have to convert it to radians. Once again, we use this canceling of units strategy, right? So we want to cancel these degrees. So we want to have a degree up top here and we want to get rid of it with the degree down there, right? So obviously those cancel, we'll be left with our answer in radians. When converting from degrees to radians, obviously we have to multiply by pi over 180 degrees, right? Pi radians over 180 degrees. When converting from radians to degrees, we want to multiply to cancel our radians, right? So we're going to have radians here. We got radians down here. We'll cancel them. We'll be left with degrees. So we want to multiply them by 180 degrees over our pi radians. Okay. All right, moving on. We got, obviously I talked about canceling units right there. Now let's talk circumferences. Okay, so the circumference of a circle is going to be 2 times pi times the radius, also known as the diameter times pi. All right, now what if we need the arc length, right? So we just want part of a circle, we just want part of its length, right? So the length here would be right along there. Our equation for that is going to be the number of degrees of that interior angle of that arc length over 360 times pi times our diameter, or 2 times our radius, whatever you want to use. Okay, now what if we have it in radians? Okay, let's say that we have that initial angle in there in radians. We can use that over 2 pi radians, since 2 pi radians are the measure of a full circle, and multiply that by pi times the diameter, or pi times 2 times the radius. Okay, once again, area. What if we want the area of a part of a circle, as in this example here? We take that 120 degrees, put it over 360 degrees, since that's the full degrees of a circle, and then we multiply by pi r squared, which is the formula for the area of a circle. We can do the same thing with radians as well. Okay, a polygon. What if we need the measure of an interior angle of a polygon, such as in blue and black here? Okay, what we're going to do is we're going to take our number of sides, we're going to subtract 2 from it and multiply by 180, then divide by the number of sides. So if we had, for example, a square, we would have 4 sides minus 2 times 180 divided by 4. We see we end up with 90 degrees, which obviously is indeed the correct answer there. Okay, so that right there, it took us about 15 minutes. I do have one more thing I want to cover, so I'm going to quick add it in here. So what I want to add here is imaginary numbers. I want to quick touch on one thing with it. So if you have I, which is your imaginary number, to the power of 1, obviously that's going to equal I. Now, if you have I squared, then that's going to equal -1. Now, if you have I to the third, I to the third is going to equal -I. Okay, and I'll make that a 1 more obvious. Okay, and then I to the fourth, if you have I to the fourth power, then I to the fourth power is just going to equal 1. Now keep in mind that this is also going to loop. So if you have I to the fifth power, that's also going to equal I. If you have I to the sixth power, that's also going to equal -1. If you have I to the seventh power, then you're also going to have -I. And if you have I to the eighth power, then you're going to have 1 as well. So you see that that's just going to loop every time you add 4, right? So if you have I to the ninth over here, have I. If you have I to the 10th, you're going to have -1. If you have I to, then you're going to have -I. If you have I to the 12th, then once again you're going to have 1. Okay, so just understand that that loops there. Okay, then that's going to take care of your imaginary numbers for you. So that takes us through our review of all the math formulas and equations. Now let's go and get into some practice with the math no calculator section and then the math with calculator section. Alright, so let's go ahead and review some problems for the math no calculator section first. We'll do this for about 7 or 8 minutes, and then we'll move to the math with calculator section. So these problems will be from practice test 5. I'm just going to go through a couple that I think are important to review. So we have question 5 here. we have k plus, or the square root k plus 2 minus x equals 0. K is a constant, x equals 9. What's the value of k? Well, let's go ahead and plug in 9 for x. So we got minus 9. We'll add 9 to each side, so that way we can square that square root, get rid of the square root. So now we have a 9 over here. Okay, so we got 9. Just make this a 9. Now we can go ahead and square each side. That's going to get rid of that square root. We know 9 squared is 81, so we're going to have 81 is equal to k plus 2. We subtract 2 from each side. We're going to get that k is equal to 79. So the answer there is going to be D. So this one right here is just kind of dealing with algebra, right? So just a quick little review of algebra for number 5. Answer there is going to be D. Next one I want to cover is going to be number 7. Number 7 is an inequalities problem. I want to cover this one because it's a word problem we can solve quickly if we have the right strategy. So let's go through it. Jackie has 2 summer jobs. She works as a tutor, which pays an hour. She works as a lifeguard, which pays $9.50 an hour. She can work no more than 20 hours per week. Thus, 20 must be greater than x plus y. Okay, so we go ahead and find which ones has 20 is greater than x plus y. We see we have it here and we have it here. We don't have an A. A is wrong. D is wrong as well because it has it as x plus y being more than 20. Okay, moving on. We got our only difference then between these two is going to be in this sign right here. So we see that it says, but she wants to earn at least 220 bucks per week. Okay, so that 12x plus 9.5y has got to be greater than or equal to 220. I see that I have that in option C. So my answer there is going to be C for number 7. Okay, we just quick verify x and y mean what we think they mean, where we see x is the number of hours she tutors, y is the number of hours she works as a lifeguard. So boom, that's correct there. Okay, we solve those ones quick by just identifying wrong answer choices, getting rid of them. Process of elimination is our best friend there. Okay, number 8. I want to cover 8 because it deals with intercepts in a word problem, right? Sometimes people can get confused on these ones, so I just want to cover this real quick. In air, the speed of sound s in meters per second is a linear function of the air temperature T in degrees Celsius and is given by s of t is equal to 0.6 plus 331.4, which of the following statements is the best interpretation of 331.4 in this context. When you're asked to interpret an intercept like this in a word problem, what's going to help you is if you put in 0, okay, for t, right, for whatever variables here. In this case, when we put in 0, 0.6 times 0 will give us 0. We'll see that then our speed of sound s in meters per second is going to equal 331.4 meters per second when our temperature in Celsius is 0 degrees. So we look at option A, the speed of sound in meters per second at 0 degrees Celsius is what 331.4 is. So our answer for 8 then will be A. Okay, so these ones, if you're dealing with a word problem like this and you're given an equation, just make sure that you're using simple methods, right? If you try to overcomplicate it, you might get it wrong. Just keep it simple. Okay, you see that you're asked for the interpretation of an intercept. That means you want to have 0 as your variable then. Okay, so that one right there, not too difficult, but sometimes it trips people up. That's why I wanted to cover it real quick. All right, next ones I'm looking at. Okay, I see number 10. Let's go over number 10 real quick. Number 10 looks interesting. Okay, some of you guys might be a little bit frightened by it because you see a lot of variables. Let's go ahead and take a look at it though. So we have if a squared plus b squared equals d and a times b equals y, which of the following is equivalent to 4 plus 8y? Okay, well we know 4z is going to be 4 times a squared plus b squared, and we know that 8y is going to be plus 8ab. 8ab, because we have ab is y. So we have 8ab. Now we can go ahead and distribute this 4. Okay, and now what do we see as our pattern when we do this? Well, we see we're going to have 4a squared plus 8ab plus 4b squared. Now immediately when you see this, you should be thinking that you have a double in your middle term and you have the same outer terms. Now if you have that, then what you want to look at is you want to look at the fact that you know you're going to have something where your situation is going to be an x plus a y squared, because you know when you have something like an x plus y squared, you're going to end up with x squared 2xy plus y squared. So you see when you have this middle term being double the outer term, and you know you're going to have a pattern like that, right? And you can also see that in all your answer choices over here. Now, you know that your x and your y have to be the same, okay? They can't be different, so you can get rid of A and you can get rid of D. Then you're between B and C. You know that 4 times 4, okay, 4 times 4 would give you 16, so you know that that's going to be wrong. And you know your answer there is going to be B, because you'd have this 2 times the 2 on the other side to give you that 4a squared. So your answer there would be B. All right, so that one right there, not too difficult, just understanding those perfect squares, okay? So 10, answer there is going to be D. Okay, I wanted to cover that one because I know that sometimes people get frightened when they see so many variables, so I wanted to show how simple it is. All right, let's look at some other ones. I look at let's find another one that would be really helpful here. Okay, I covered some of these other ones already, so I'm not going to cover those. And I think I might cover those ones. I might have covered those ones in a different one, so I just want to find some that are, oh, here's a good one, right here, 18. This is a good one to cover. I want to cover this one. All right, so the system of equations above has a solution, x, y, what's the value of x? Okay, if we're asked to solve for x, that means that that's what we want to solve for. So what that means is we want to substitute in this y equals 2x for y. Okay, so we substitute that in for y. We're going to have 2x then 2x, which was going to be 4x. So I'm going to go ahead and get rid of that. We have 4x. We know half of 4x is going to give us 2x. Now we have 2 equals 21 over 2. We're going to divide each side by 2 here to solve for x. Okay, dividing that side by 2, we know 21 over 2 again is equal to 21 over 4 as our answer for 18. Okay, the reason I wanted to cover this one is because it deals with substitution. I wanted to show you when we're asked to solve for x, right? And obviously we could have solved for y and then solved for x, but we want to make sure we solve for x first, since that's what we only get points for. We don't get points for solving for y, so we're not going to. So I wanted to focus on this one because it's going to show us that we don't want to take inefficient routes, we want to take efficient routes. I wanted to remind you of that before you take your SAT practice test. All right, let's cover some other ones that I see that I want to cover. 17, that's just an algebra problem. We already covered things like that. All right, looks like we covered a lot down here. Let's go ahead and cover number 20 though. Okay, I'm going to erase this. Let's cover this one. The reason I want to cover this one is because we haven't really done much with geometry yet as far as review, and I also want to show you something that's going to help you be more efficient with this one. Okay, so obviously you saw the answer there. That's okay though. I'm going to go ahead and show you how we're going to do this one to save time. Okay, this was in a tip video, but that's okay because you haven't seen the tips in a while. All right, so intersecting lines R, S, and T are shown below. What's the value of X? Okay, so the big thing here is understanding that we want to only solve for the angles that are going to help us get to our answer. So the angles that are going to help to get our answer here is going to be this angle here. Okay, we know that's a long line R, so to solve for the value of X, we need this angle here. We'll do 180 minus, we'll call this angle Y. 180 minus Y is going to give us angle X. We want to solve for angle Y as quickly as possible. All right, so the first thing that I'm seeing right away, I have this 106 along line S, so I go ahead and do 180 minus 106. That's going to leave me with 74 right here, 74 degrees. Now, since I know that that's 74, what I can go ahead and do then is I can go ahead and do that 23 plus that 74. I can subtract that from 180 to give me my answer for Y. So 180 minus 23 plus 74, we know that 23 plus 74 is 97. 180 minus 97 is going to leave us with 83. Okay, so we know Y is going to be 83, thus we know our answer is going to be 180 minus 83, obviously is going to leave us with that 97 that was right there, right? So our answer for the value of X, 97. Okay, notice how I didn't go through, I didn't mark that this was 106, and I'm going to put this in red so you can see the difference. Notice I didn't go through and mark this one as 106. I didn't go through and mark this one as 74. You could have, but it's just kind of wasting your time. You saw I didn't go and put this one as 23. You saw I didn't solve for this angle here or this angle here, even though they're going to be the same there. But yeah, you saw that I didn't mess with angles that aren't going to help me get to my correct answer. I was really efficient in that way. And as you get into other ones, right, sometimes you'll see a problem where you have lines like this, right? And let's say we have a random line too that just goes down like this. Okay, sometimes you'll see more lines than that. Just understand, solve for the least amount of angles as possible to get to your correct answer. That way you're saving yourself time. All right, so hopefully this was helpful. Now let's go and switch over to the math with calculator section and do some problems there to review. All right, so now let's go ahead and go through a few questions of the SAT math with calculator section, once again from SAT practice test 5. So looking at question 8, one thing I want to point out, this is where we're going to start. Okay, one thing that is clear to me right away, that is something I think that you should just understand and remember tomorrow when you take your practice test and when you take the SAT, is taking the most efficient route possible. One thing that jumps out to me right away is I see 1.6 plus 11.2 plus 12.16 and plus 0.64. Thus, by solving for that term with no x by it, I can find my answer. Whereas if I was to find this part first or this part first, I would have to, and by this part I mean this part with the x squared term, I would have to go on and then solve once again for this term or for this term. So by doing this, by solving for this last part of the problem, right, the part without an x, I save myself time. So let's go ahead and do that. We have negative 2.4. Obviously, we're going to have to multiply that by negative 2.4. We can go ahead and put that in our calculator right now. Since this is the with calculator section, we see that that is going to give us 5.76. 5.76. Next up, we've got that much minus negative 6.4, which means we are adding 6.4 to that. Okay, we add 6.4 to that. Let's put that in our calculator. That's going to give us 12.16. Our answer then must be C. Okay, so that one right there. By doing this, we're saving us so much time because we don't have to deal with this x term we don't have to deal with it at all. So that's one way we can do this to save time, right? Anytime on the SAT math section, the math with calculator, the math no calculator, you can identify one part of your problem that can give you your answer on the multiple choice. That's going to be the way you want to go. You want to save that time. So go ahead and implement that strategy, right? That's really going to help you out. So answer there for 8 is going to be C. Let's go ahead and find another problem that we should review before tomorrow's practice test. One thing we can do is let's quick review 9, right? It's going to be really, really fast, but I just want to show you canceling units really quick. So we have in the 1908 Olympic Games, Olympic marathon was lengthened from 40 kilometers to 42 kilometers. Of the following, which is closest to the increase in the distance of the Olympic marathon in miles? So obviously we see an increase of 2 kilometers. We know that 2 kilometers, we go ahead and cancel kilometers since we have 1 mile is approximately 1.6 kilometers. We put kilometers on the bottom. We have 1 mile per 1.6 kilometers. And we'll go ahead and cancel out kilometers there. So we're going to have 2 over 1.6. We can put that in our calculator. And we see that that's going to give us 1.25 as our answer. Okay, so our answer there will be B for number 9. All right, moving on. We can go and find another one that we should review before tomorrow's practice test. Okay, let's see here. I see problem 12, right, dealing with XY solutions, solving for X. So we talked about in the no calculator section how we want to solve for only the variable that we're asked to solve for. In this case, that is X. So what we want to do is we want to get rid of our Y variable and sub in for X. So we see that we have 1/2 Y here is equal to 4. We see we have minus 1/2 Y right there. So we're going to have X then minus 4, since 1/2 Y is equal to 4, is equal to 2. At that point, we add 4 to each side. We know that 2 plus 4 is going to give us 6, so we're going to have X is equal to 6. Okay, so our answer for number 12 there is going to be D. All right, moving on, let's go and find another one that we should review. All right, let's see here. So we've got this one right here. So we've got a two-way table, right? I want to review two-way tables as well, just because some people can get tripped up by them. So we have in a survey, 607 general surgeons and orthopedic surgeons indicated their major professional activity. The results are summarized in the table above. If one of the surgeons is selected at random, that's important. Which of the following is closest to the probability that the selected surgeon is an orthopedic surgeon whose indicated professional activity is research? So we have orthopedic surgeon in research. Okay, so we go across from orthopedic surgeon and then down from research. We see that that's going to be 74. Now keep in mind that we're asked for the probability of the selected surgeon, which we know is selected at random, so that's out of the total. Okay, so it's 74 out of 607. So we can put that in our calculator and see what we get. When we do that, we're going to end up with 0.122 as our answer. So our answer there is going to be A for number 14. All right, moving on, let's go ahead and find another one that we should review. Okay, so that was your review for two-way tables. Let's find something else here. Okay, we see that questions 16 through 18 are paired ones, so we're going to want to avoid that because we might not want to do all three. Okay, I see 15, a statistics question. We haven't covered statistics yet today, so I want to cover that. A polling agency recently surveyed 1,000 adults who were selected at random, that's important, from a large city, and asked each of the adults, are you satisfied with the quality of air in the city? Of those surveyed, 78% responded they were satisfied with the quality of air in the city. Based on the results of the survey, which of the following must be true? Option 1, of all the adults in the city, 78% are satisfied with quality in the air. No, because we don't know the margin of error, and since we only surveyed 1,000 adults, right, we can't say for sure that of all the adults in the city, 78%. We could only say of our sample, 78%. So 1 is incorrect. Okay, we can't say that's true, so we can go ahead and get rid of C, and we can get rid of D. Option 2, if another 1,000 adults were selected at random from the city were surveyed, 78% of them would report they are satisfied with the quality of air in the city. Okay, once again, we can't say that, right? If we surveyed another 1,000, it might be 79% or 80% or 76. So we see 2 is going to be wrong, and our answer there is going to have to be none then. Okay, our answer would be A. We don't have to worry about 3 because we don't have to deal with it since we already know 1 and 2 are wrong. All right, so answer there is going to be A for number 15. Now let's go and find another question that we haven't reviewed yet. Okay, we've covered pretty much most things at this point. There's not really a whole lot. Okay, we already covered some stuff with geometry. Okay, number 20. I like number 20 because it's a logic and reasoning question. I think it's important to review that so we don't get too caught up in equations. Okay, the figure on the left above shows a wheel with a mark on its rim. The wheel is rolling on the ground at a constant rate along the level straight path from a starting point to an ending point. The graph of y equals d of t on the right could represent which of the following is a function of time from when the wheel began to roll. All right, well, we know our wheel, it's rolling on the ground, okay? Now, we see that we have it going up and it's going down, right? Now we know that that can be the height of the dot, right, or the distance of the mark of the rim from the ground. Okay, that height, because as it rolls, we know that this dot is going to go down to a height of 0 and then back up to its maximum height, and then down to a height of 0 and then back up to its maximum height. So we know our answer there is going to be D for number 20. Okay, and let's go ahead and run through why A, B, and C are all wrong as well. The speed at which the wheel is rolling. Okay, that's not what this is going to be because we know it's rolling on the ground. It's going to be a constant speed because there's no hill. Okay, option B, the distance of the wheel from its starting point. The distance of the wheel from its starting point is only going to go up, right? Because it's just going further away as it rolls. Option C, the distance of the mark on the rim from the center of the wheel, that's constant. That is just the radius. All right, moving on. Let's go and find another one we want to review, okay? Let's go ahead and do, I like 19 here, okay? I like 19 because it's a geometry one dealing with 30, 60, 90 triangles, which is something that's good to review because it shows up fairly often. So we have triangle ABC. We're asked for the length of A to D. Okay, we know we have a 30, 60, 90 triangle. We see that this whole triangle is an equilateral triangle. Obviously, if we were doing ABC, that triangle, this large one out here, we know that that's going to be an equilateral triangle. All right, so we're asked for the length of AD. We're told that BC is 12. Okay, if BC is 12, we know that the DC is going to be 6, and we also know AD is going to be 6, right? Because if BC is 12, since this is an equilateral triangle, we also have a 12 here. We know that this is a 60, 30, 90 triangle in which the side opposite 30 will be half the hypotenuse. Thus, our answer there is going to be B for 19. Okay, this one right here, that's why we wanted to review that, is because it's a 30, 60, 90 triangle. Keep in mind the side opposite of 60 would be 6 root 3. Okay, 6 root 3 would be this height here. All right, moving on. Let's see what else we want to cover. So we've got the equation above, A is negative. We don't want to cover that one. We've already covered word problems. I'm not seeing anything big. We've pretty much covered everything. It looks like our 8 minutes is pretty much up. So at this point, I'm going to go ahead and end the math with calculator review. We really covered most of what I wanted to. So at this point, we're going to go ahead and end this. So hopefully today's video was helpful. If it was, there'll be a donation link in the description. I would appreciate any donations you could send my way. These videos take a lot of time, planning, and effort, so I definitely appreciate that. If there's any private SAT tutoring I'm doing, private college admissions consulting I'm doing, or private college essay proofreading I'm doing, that'll be linked in the description as well. As always, make sure to have a great day and like, share, and subscribe.